Sounds good. I appreciate it. Great to see everyone. Hope everyone's having a great day and enjoying the conference so far. Really excited to talk with you guys about something that I'm really passionate about. Just as she mentioned, this session is on dimensional data modeling in the modern era. So we're going to talk a lot about dimensional modeling over the next half hour. Real quickly, I work as a principal data architect at Onyx, which is a global consulting company. We work with a lot of large companies on data and AI initiatives all over the globe. I've been building data platforms for quite a while, about 17 years experience, of which I've worked for multiple startups, Fortune 500s, and pretty much all sorts of folks in between. I've co-authored 2 books, Pro Database Migration to Azure and Unlocking DBT. Unlocking DBT came out last year, and it's all about end-to-end using DBT, largely from a data engineering perspective. So definitely check those out if those are of interest and you're wanting to learn more. Very active in the data community. I've ran tech events, ran user groups, spoken at a lot of different conferences. So hopefully maybe at an upcoming event, I can run into some of you that are here today. All right, so real quickly, just a quick look at the agenda of what we're going to hit on today. So we're going to look at a brief overview of data modeling techniques and why it is important. We'll look at what is dimensional data modeling, what role does it play in the current data landscape, how it has evolved over time, and then why it is something that is still relevant today. When the concept of a data model is can be very skewed in terms of how people think about this. A lot of different systems will have things that it calls models. DBT has models. So when you say data model, you maybe not always talking about the same things when you're talking with folks. So I want to define what I mean by that first before we dive into different types of models. But a data model is the blueprint that defines how data is organized, stored, and connected in a system. So in the case of what you're seeing here, you see a very simple entity relationship diagram that shows tables or views that are getting created and how those things are connecting up. What fields are part of those? It's how you're structuring your data. Within building data solutions and building databases and constructing applications, it's important to have a blueprint that you're building against, which is that underlying model that you're working with before you build things, so you know how you're building it. Just like when you're building a house according to a blueprint, no one's going to go and build a house and just take a bunch of 2x4s and pieces of wood and just go start building it. They're building it according to a plan. Today, technology has gotten so much better than what it has been in the past and so good and easier to use that things like data models will often get overlooked. A lot of universities and boot camps and different programs that even teach coding haven't often, at least historically, taught a lot of data engineering concepts. And so this is an important one that can get overlooked. That's very relevant and important before you get into data science things. And I know a lot of you folks who are probably joining this conference are working in data science and AI, but you don't get those things without having a good data engineering framework underneath it. There's a lot of different types of data models, a lot of different types of blueprints that you can build things with. Here are 4 of probably the main ones that I would consider here. And these different modeling techniques will fall on different levels of the normalization scale and how you think about them. So first, before I talk about the modeling types, I'll talk about what normalization and denormalization is. So normalization is a set of rules used when designing, organizing a database that ensures data integrity and eliminates data redundancy. So it's basically data broken down into smaller, more manageable units and organized into separate tables. Denormalization is the process of intentionally introducing redundancy in a database design in order to improve performance of reads or simplify data retrieval. All of these models have their place in the data landscape, and each of these models can fit kind of depending on what your business need is and your use cases are. They can all be very relevant and even work together. It's not oftentimes you're going to pick one of these and that's going to be the only thing you're going to do. A lot of times these can go together. On one end of the data spectrum, on the very normalized data, you have data vault modeling technique, followed by third normal form. Third normal form in this aspect could be also referred to as transactional, relational, Inman. These all kind of fall into that third normal form. And then you have dimensional modeling, which is what we're going to really dive into today. And then on the far end, you have one big table, which is just taking all of this data and putting it into a single table, and then having your consumption teams consume data from that. There are other model types, things such as open data models, which can be specific to industries. Teams can use combinations of these different modeling types, or you can have no data model, which is a data model in and of itself if you've given no consideration to the design. Regardless of if you have or not, there's still a model that is making whatever you're doing work. You also have different architectural frameworks that can support these that aren't exactly the data model, but they're terms that you may hear around things like data fabric and data mesh, centralized federated architectures, lakehouse architectures. These are all sort of framework architectures that your model can live within and function, but not necessarily how exactly you're modeling the data. Another way to think about these in terms of the normalization and denormalization. Normalization is when you're typically modeling where you need faster writes. Denormalization is when you need faster reads. So reporting and business intelligence and building consumer data products, typically denormalization is going to be a faster way to get that data, whereas if you're building transactional systems or you're building like stuff to do auditing and change tracking, probably makes a little more sense to be a little more normalized. Real quickly here, one of the biggest issues I see with working with data teams today, and I get the opportunity to work with a lot of them, is a lot of teams get lost in short-term solutions when they're thinking about how they're building their data products and they're building their data frameworks, and they never stop to consider the big picture. I've worked with a lot of teams where you have folks, they're focused on building things and they're getting business requirements, but they're receiving the business requirements, they're going and building it, business gives them another requirement, they go and build it, and there's never really a lot of consideration given to the overarching design and what that underlying model should actually look like. The clients that we're working with today is basically untangling this. Teams built quick and they delivered fast, but they created a lot of tech debt when they did it that could have been mitigated or not have done if they had just taken a little time up front to look at the big picture. These are some pros and cons of the different data models. For the sake of time, I'm not going to run through all of these, but if you want to screenshot this, or we'll make the slides available after this, you can get this. The thing that I want to point out about this though is there's different modeling techniques can apply to different scenarios. And I'm not going to come in and say, hey, you've got to do dimensional modeling and this is the one and only way, or any of these other modeling types. It can vary, and it can vary based on your business need. And there's pros and cons to each one, and it's going to be up to you and your team to figure out what type of model fits the scenario that you're using. These can also, and I mentioned this earlier, these can work together, so it's not like just to pick one. These things work together, and oftentimes they will work together because you have multiple needs that you need to do with data. No one wants to go and build multiple data warehouses for different needs. You should think about how you're structuring your data warehouse and your data products in a way that can be multi-use. You're not building it for a single need. So in terms of incorporating these, this is just an example. This is something that I've seen before. I'm not telling you that this is the way you need to go and build your data warehouse. Ultimately, I think you've got to look at your business needs, your use cases, and figure out what makes sense. But this is just showing an example of how all of these things can work together. Working from left to right, typically when you're building these solutions, you've got to get the data from somewhere. So your first step there is your raw data, and typically it's stored in the relational format. Even if you have unstructured, semi-structured data, you need to get that into a relational format to consume that data through a warehouse. This is also a lot of times called a bronze layer. It can be called a raw layer. Bronze if you're using a medallion naming, but it's generally relational data that is getting stored at this point. You could have a data lake that even sits upstream from this, but this is simply where data is starting to get read and transformed from. In your middle layer, so your silver layer, or also could be called your staging intermediate layer, you could have a transactional. You could build that to be transactional. You could use that just for transformations, or you could actually create a data vault model that lives there, which is a layer that you can use to be able to look for adaptability and auditability. And I've seen folks do this. Data vault models are not good for reporting and for analytic and data scientists generally to consume data from. Data vault models will actually even recommend that a dimensional model sits on top of it, but you can have this upstream to be able to do some stuff around auditing and some change tracking and things like that. Your gold layer, or your kind of your foundational data model here for business intelligence reporting, is where your dimensional model can live. So this is data that's separated out into facts and dimensions, broken up, but it's that underlying model. And then in your final stage, this is debatable about whether or not you have this or not, and there's pros and cons outside of the scope of this talk on whether you should do this or not. I think there's a combination of teams that use these, but you can have a one big table that sits on top of your dimensional model that pulls these things together, that makes it ready to consume through BI tools and consumable if users are trying to pull this in. But basically, it's taking the data from your foundational model, dimensional model, putting it into one big table, makes it very easy to be consumed. You could take BI tools, Tableaus, Power BIs, Lookers of the world, and set those directly on top of your dimensional model and just consume it from that. But again, there's pros and cons and different ways you can do that, but it's pretty common to see one big tables sitting on top of a dimensional model for that data to be consumed. All right, so let's jump into dimensional modeling. So this was kind of the main focus of the topic, and talk about this. First, I want to go back in a little bit in time and look at what the original intention of this was when it was originally created. So dimensional modeling, which, as you've probably heard me maybe say multiple names already, has multiple names for it. So dimensional modeling can be called Kimball, can be called star schema, snowflake schema, sort of, which is just kind of an iteration of a star schema. These are all things that can kind of reference this sort of build. But it was originated in the 90s by the Kimball group to solve two key issues. And you can read all about this in the Data Warehouse Toolkit book. I highly recommend reading this book. Yes, it has some dated references in it, but a lot of the concepts that it teaches are still very relevant today, and are still followed by probably thousands of organizations. I'd still say this is probably one of the most popular modeling techniques when it comes to analytics. So it's still very widely popular today. If there was one book that I would tell you to read, this would be number one on the list, despite the most recent copy being published over a decade ago. It's still very relevant. In this book, they highlight, this is directly from the book, the two key reasons that this concept was conceived and why they advocated for it. Number one, deliver data that's understandable to the business users. And number two, deliver fast query performance. When this modeling technique was created, everything was pretty much stored in relational databases. You had to use a relational database to put it in it. These were systems that were optimized for writes. You were reading data that was a lot of times transactional in nature. So it was important to be able to have a structure to deliver query performance. Some people will debate this and say it's not relevant today because of the advancement in infrastructure and technology, which I disagree with. But even if you could make that argument, it still doesn't solve for the first one, which is delivering understandable data to your business users, which is still extremely relevant, maybe more relevant today than even when it was then. Just note, this is a concept that is decoupled from any specific technology. Dimensional data modeling is not specific to any technology. You can do it with no matter what you're using. It's just a way that you can structure your data and set it up. So how do dimensional models work? Dimensional models work by organizing data within generally two main table types. There are some other types, but generally speaking, it's going to be a factor dimension. Facts are tables that store business processes that you're trying to measure. So this is just something that you want to be able to measure and your consumers need to be able to measure. Dimensions are tables that store descriptive attributes. These are things about how you group and filter your data. So these can be things like people, places, things, concepts like time and dates, and so forth. But yeah, facts are your business measure, and then dimensions are how you group and filter and aggregate and view those measures. On the left-hand side, you can kind of see a very high-level diagram that shows what this looks like and why it gets its name, star schema, where in the center of this star, you've got a fact table, and then you've got relationships, foreign key relationships out to dimension tables that connect to those. So your fact sits in the middle. On the right-hand, bottom right-hand side, you can see what this would look like in terms of a really simple ERD, where you could have a sales fact table, which can have things you want to measure like amounts and discounts and taxes. And then that joins off to various dimensions that can have a multitude of attributes in them. These dimensions are very, very basic, but typically you can have access to hundreds or thousands of different attributes across your various dimensions that can connect to it. So it gives you a framework that you can go through and very quickly be able to utilize this data. Quick note here, facts and dimensions can oftentimes be used just as labels, and they don't oftentimes represent what you are seeing here. There are some vendors that I've seen that teach kind of an iterative approach to dimensional modeling, where it's taking something and it'll call things dimensions, but they're not really dimensions, or it'll call things facts, but they're not really facts, where they're effectively facts are created to be one big tables. You don't end up with this structure, this kind of foundational model of how things connect. It's basically your dimensions are just intermediate objects to allow you to get attribute data into a single fact table, but it's ultimately just a one big table. So if you do see these, don't just assume that this is what it is. There's a lot of versions of this that people create that is not the same as this, and some of those are some anti-patterns that I think can lead you down the wrong road if you're not careful. One other thing on the dimensions, an important concept of at least the Kimball style, is creating conformed dimensions. So when you're creating dimensions, these are objects that you should only be creating once. Think about them as master data. So if I have something like a store, customer, or product, I only store those in one place. I'm not going to create a product category, a product type table that you would typically do like in a transactional system. Everything's going to be very denormalized, and it's going to be put into a single table. If you start breaking those apart, that's how you end up with a snowflake schema, or just building something that's more transactional, which kind of breaks some of the benefits of actually building dimensional models. Designing a dimensional model, just real quickly, we'll hit on these. A bus matrix is a really important tool to use. I don't see a lot of teams using this anymore. I use it all the time because it really helps illustrate what you need to be able to build. But this is a tool just used to organize the development of a dimensional model. This is created in an Excel spreadsheet in which, when you're gathering business requirements, you define what your business processes are, and that's what you see in that first column. In the further down the row columns, you'll have your dimensions that you'll define things here like channel, customer, date, employee, and then you'll define your grain. This is not part of the original context of building bus matrices, but I like to think about my grain when I'm looking at this from a high level on how things are connecting up. And then what I do is, based on the business requirements that I'm gathering, I'll map a business process to a dimension, which basically gives me the insight that I need to understand what I actually need to build when I build the transformation logic, and ultimately kind of design what those end tables actually look like. This is very high level. This is just looking at it from a business perspective of, these are the processes that my business says they need to be able to track, and here's the dimensions that those need to be able to connect to. Source to target mapping, this isn't really, I wouldn't consider this to be synonymous with dimensional modeling, because no matter what you're using, if you're using any sort of model, you're probably maybe doing something like this anyways. But a source to target mapping adds details and defines what's actually being built. So some teams or some architects will go through and build ERDs, and they'll construct it that way. I typically, when designing a dimensional model, I'll build it from the standpoint of the source to target mapping, in which I'll define all of my columns, add my metadata, figure out what the relationships are, and then connect it, and then I'll map it to the source that data is coming from that needs to feed into that, and build it that way, and then back it into an ERD just for a visualization sake later, because it's easier to understand, but I'll usually start here to go through and connect those things. Once the source of target mapping is created, I can pretty much just go and hand this to a data engineer, and they can go and start building it. They have all the information that they need to go and build it. Granted, there's patterns and things like that outside of the scope of this that are important to follow to make that repeatable. High level steps to create. So first step, business requirement gathering. The more the better. It's extremely important. Regardless of whether you're building this or not, and you're a data engineer or working anywhere in data, largely, as long as if it's not in a DevOps role, you really need to understand what your business needs are. It's extremely important. I would say it's the most important thing in building dimensional models. Translate those into technical requirements. You can use a bus matrix to be able to do that. Determining your grains, you need to understand the granularity of your tables. And typically you want to build things at the lowest granularity that you need, and you can always aggregate up. You can't aggregate down, so you want to define it at a low granularity that is useful to your business. Defining your table structures through things like source to target mapping, vetting the design, which is important, and then starting development and repeat. The reason the repeat is there is when you're, a lot of teams will break these up into smaller segments as they build them. So you'll hear the term a lot, marts. So you can break these up in marts, and typically if a team is working on this, they're working on one mart at a time. So you go through this process to build it, and then once you've built it and supplied that need, then you start back over building a new mart for another business area. And that process just continually repeats. All right, so some common criticisms, agree or disagree. So I'll hit on some common criticisms that I hear from folks about dimensional modeling, and just basically hit these head on and tell you whether or not I agree or disagree. So a lot of folks will say, or some folks, I won't say a lot, some folks will say it's no longer applicable because of advancements in infrastructure. Disagree. We kind of hit on this a little bit earlier, so I spoiled this point a little bit, but I believe this is false. I think some of the advancements in technologies actually make more sense for dimensional modeling, especially things where you have like columnar data stores, where data can be stored in columnar formats, the level of compute, et cetera. I think it adds to the benefit here. But even if you could make the case that infrastructure has came a long way, it still ignores some of the other other benefits, like the business value that it brings in terms of some of the flexibility. And we're going to hit on some of those other benefits here in a minute, a little deeper. Doesn't play too well with unstructured or semi-structured data. With this, I tend to agree and disagree. The reason that I agree is you can't get unstructured and structured data, or unstructured and semi-structured data, into a dimensional model in its raw format. It needs to be converted to a structured format. So typically, if you're working with data like that, it's going to be a process that's going to live upstream, but you can convert it to be more structured data, in which case it can become part of your dimensional model. Challenging to use with real-time data. I agree here. Real-time data needs to be written quickly, and it works better as an upstream model. Dimensional models typically is data being transformed, and they can be pretty heavy, time-consuming transformations in some cases. Real-time data needs to be fast. Dimensional models work best when you can batch process. There are folks who have done stuff where they've done it in a real-time-esque sort of build. But typically I would say real-time data is probably best served upstream. And it's very common to have upstream real-time streaming processes, and then that data eventually get developed into a dimensional model to be consumed. Requires upfront work and slows down progress. Hey, infrastructure is really fast. It's inexpensive. We need to move quickly. This is going to slow down our progress. I tend to agree and disagree here. I think it can be both. It can be, when you're building dimensional models, it can be slow in the beginning because you need to gather those business requirements. You need to understand the business processes and being tuned with the business, which I would argue you need to be doing anyways. And there's some initial work that has to be done that you don't have to do again. Notably, like creating those initial dimensions that need to be created on that first iteration and those initial fact tables. Once you do that and you have patterns in place and you've got that initial framework, it actually speeds up over time because you're just going through and adding on to the model or making adjustments to the model as opposed to creating something new every time. So it's not a hit a reset button every time you need to add something to it. It's you're iterating on it, you're adding to it as you move along. So it can be slow in the beginning, but it's going to reduce the load as it evolves. When we talk about the benefits, I want to use an example from a client that I worked with. So within the past year, I was working with a Fortune 500 client that if I told you the name, I'm confident everyone on this call would know exactly who they are. We were looking at some of the stuff that they were building in DBT on Databricks and identifying where they were building a lot of their stuff as one big tables. There was a lot of redundancy. There was a lot of inefficiencies in the stuff that they were building. And so we advocated very heavily, like, hey, you need a dimensional model to be able to support this. So they agreed, but they wanted us to show it, to prove it to teams, like, hey, yes, this is what we should be doing. So they gave me an existing financial process they had that was pretty complex. It was written as a one big table and said, take this use case, turn it into a dimensional model. The chart that you see on the right side there is the exact chart that we showed this client to do a comparison. So there may be some things on there you're like, hey, what is this? If you're not familiar with DBT, I didn't want to remove those because I wanted to show you exactly what we showed to the client. In this case, we had a one big table that was very complex. It was over 1,000 lines of code that was being run to produce this. It was very hard to go in and make adjustments to it. But in this particular build, we had over 14 different models in DBT. These are individual SQL files that we're running to produce this. 2 tests, 1 seed file, no hooks, 1 measurable column, and then around 25 number of attributes that were accessible. We recreated this, loaded this into a dimensional model. In the dimensional model, we increased the number of models to 21 because we needed to build out those dimensions. We added a large number of tests. We went from 2 tests to 179 tests. We added more seeds. We added some post hooks, which were inserting dummy records into our dimension tables, so everything could be a full join. We went from 1 to 6 measurable columns. So there's 5 additional business processes, business measures that could be consumed through this table. And we extended the number of attributes that were accessible to this to over 250. So we went from 25, we 10x the number of ways that our consumers could aggregate, group, and filter this data. And we actually saw a reduction in time on doing this. Now, comparing these two things, typically a one big table is always in a one-to-one comparison, should always be faster. And in this case, we detuned that. It would have been faster. But seeing this, that it was actually comparable performance, and we actually opened up a whole new world of use cases, was something that the client got extremely excited about and have since made the switch to going back and building dimensional models at this layer of their process. So if you look at the bottom left, just what the client said about this is the client's own words. This isn't just me saying it, but I think it highlights a lot of the value here, is that they agreed that with this was significantly easier on consumption teams. We don't have enough time for me to walk you through and kind of show you a demo of the comparison between this, but if you look at what they were reading from that 1,000 lines of code to what they're reading from today to be able to produce the same report, it's a very dramatic difference. Went from 1,000 lines of code to an analyst writing less than 20 lines of code of consuming data through this type of model. They recognized that there would be better performance that would only increase at scale. So even though we saw better performance here, they could recognize that by reducing code redundancy and a lot of duplicativeness that was happening in the projects, that we were going to see significantly better performance as we grew. Greater flexibility with the data. This is one of the biggest benefits of using dimensional models, is having that flexibility to be able to look at data a lot of different ways without having to go make a request to a data engineer of, hey, can you add this field? Can you add this field? Which seems to be a never-ending loop of just constantly adding things. It's building things for flexibility. Reduce code data and code redundancy, which was huge. that would lead to better performance, better usability. It would reduce the data engineering load just because of the number of requests that they're getting to make changes to the one big tables. That would go away. And then ultimately, what they were maybe most excited about was this would contribute to a dramatic cost savings on compute over time, which is typically your largest cost when it comes to doing analytics within the cloud. We would see that drop quite significantly. So the value add today, just to summarize here, and we'll start wrapping up, is not only taking what this client, this Fortune 500 client said, but looking at even some additional use cases in the value adds here. First, simple to consume data from. The data structure that you are building is very, very business friendly, and it should always be very business friendly. Objects are created with intention and cover multiple needs. So this greatly reduces the number of objects needed to be maintained, tested, built, documented, etc., and reduces code redundancy. On several of the projects that I've looked at that are building things kind of following a one big table modeling technique, we could probably reduce those models by as much as 75% with some of these customers that we're working with by just structuring this data in a dimensional format. It closely aligns with the business. It creates a single source of truth. So within your data model and your underlying model, only one object contains the data that you're looking for. So you're putting a data element in one place, and everyone knows where to go look for that. Popular BI tools, things like Tableau, Power BI, etc., are built to work with these types of models. This is the way that it prefers to get data in, and for it to work as optimally as possible of consuming data from this sort of framework. And then lastly, it can accelerate your future analytical and data science opportunities. I know that this conference is a data science conference, and many of you probably come from data science backgrounds. What this does is it creates the foundational data that you can use. Downstream, a lot of data scientists have to do a lot of data engineering work just to get the data in a consumable format before they can ever start to think about building ML models and AI, et cetera. This gives you a foundation that you can start working with, that you can start consuming and utilizing your data from. Last point here is just note that you don't have to follow an exact playbook or step-by-step on how to do modeling or how to do the stuff that I've even described to you, but you should always be intentional in what you do and be able to answer why. There's a lot of thoughts that go into how you structure this thing. I change my thinking all the time, kind of based on what the business is telling me that they need, and we'll make adjustments to it. Don't just listen to me, what I'm telling you, or go and read the blog post or read books, etc., and take that for what it is, and as the gospel truth. But think about what you're doing, be intentional in what you do, and understand the reasons why. And if you do that, I think you'll be successful more times than not. With that, I want to thank you all so much for coming to the session. It's a lot of information to get out in 30 minutes, and there's a lot more deeper dive topics that we can go into this. If you do have any questions, drop them over in the channel. I'll go jump over there and spend some time answering those. If you are a DBT user and you're wanting to learn more about data modeling and DBT, we do cover this in the book, and so feel free to get a copy of that. And if you do, let me know what you think. With that, thank you guys very much.